everybody. This is Nicole Johnson, your geography instructor. Today, I have a presentation for you that involves parts of 3 chapters. So chapter 16, chapter 18, and chapter 19. We'll first start with chapter 16, and we will kind of talk about the different ways humans impact streams and how they both have positive and negative outcomes. We'll then move into desert or dry landscapes, eolian processes, and then we'll wrap up this presentation talking about coastal processes and landforms. So as I mentioned, we will start with chapter 16, which talks about essentially streams, fluvial processes. And as we are looking at these interactions, people have a huge impact on fluvial systems, especially through the process of urbanization. So as cities expand, that former vegetated soil surfaces are then converted to, let's say, parking lots and other impervious structures. And these features have an effect of sealing the ground so that water runs directly off the surface rather than soaking into the ground itself. So the impact of urbanization on stream behavior is dramatic, especially following a very heavy rainfall. I do want to take a look at this figure that you see on the screen and kind of walk you through the different colors and what's going on this figure. It's a hydrograph that is showing you the response of a stream in a heavy storm. So the green line is showing you what that water is going to, or how that water is going to react before urbanization. And then we can take a look at the blue line. You see it spiking much faster. This blue line is representing the stream flow after urbanization. Another item to point out on this figure is storm peak. So that's when the raining is the hardest. And so if we're looking at these two lines, the blue line and the green line, we also want to take a look at the lag time. And so when we're looking at that lag time is occurring because the soil is able to be saturated before that stream is going to supply a runoff or a discharge. So if we're looking at that blue line, and again, this is when after urbanization has occurred, that lag time is going to be much shorter. So you can see this lag time between storm peak is going to be shorter because of that urbanization. And then if we are, and of course that response of that urbanized stream is going to be much faster and larger than it would be prior to urbanization happening. And that, again, is the green line that you're seeing on the screen. After heavy rain, we often find more serious flooding that occurs, and that occurs in what is referred to as flash flooding. So it's a brief but intense flood that occurs more frequently. And of course, this is going to happen more frequently in urban areas. And so, most common type of flooding that occurs in urban environments. Approximately, there is about 50% of flood-related fatalities that occur when people try to drive across flooded roadways. So we want to be careful, especially in those urban areas during flash flood events. There are some things that humans have tried to do. Humans have engineered a variety of different ways to try to control structures to mitigate some of those effects of flooding. One of those structures is called an artificial levee. And it is designed by engineers, and they are typically built at the height of a given city or the height that they want to protect of a valuable farmland. And of course, they are trying to protect from major flooding events. And in the United States, most of those artificial levees are typically found around our major river systems. So the Mississippi River, the Ohio River, Missouri River, all typically have an artificial levee that is maintained by our U.S. Army Corps of Engineers. Um, Levees do have a negative effect on the wetlands, the ecosystems, and ironically on flood intensity. Now, one of the main reasons that dams have been built is to enhance river navigation, to provide flood control, in addition to providing hydroelectric energy. So the reservoir is the area behind the dam, and oftentimes that reservoir is used for recreational purposes, and also it's a source for irrigation for many areas. And so if we're taking a look at dams and these reservoirs, they are engineered structures built across a river to control its flow and typically hold back a large lake, as I mentioned, as a reservoir. And if we're looking at these reservoirs being used for recreation and a source for irrigation, in many places, they are also used, to improve navigation because of the amount of water in the river downstream of the dam can be controlled. So you are able to control the depth of the river because of that dam. And so you can control those effects of the river, again, on many of our major river systems. Ohio, Mississippi, Missouri are all important transportation corridors. And many of them are able to be important and be able to be used as transportation because these dams can control the depth of the water, and that depth is typically maintained at a consistent level that is safe for those larger barges. Dams can also be used for hydroelectric energy. And this is a form of renewable energy that is produced when the water from the upstream side of the dam flows through these tunnels within the dam itself. And as it's flowing through, it spins turbines. And within it spinning through the turbines, it's producing electricity. So there's these generators that are producing this electricity with these hydroelectric generators. And so it is very, very helpful and useful for renewable energy sources. The Hoover Dam, for an example, is capable of supplying 1 million kilowatts of power, and it provides electricity for many states, Arizona, Nevada, and Southern California. Another major function of a dam is that it provides flood protection downstream of those areas. So in theory, when those gates of the dam can be shut down completely during a wet period or heavy precipitation, and this precipitation is going to be collected or trapped in that large reservoir. And so it can help protect many of those areas and protect it from flooding. We also have another clear benefit to society that can be used as controlling flood, not only controlling floods, but producing electricity, enhancing transportation or shipping. But it also can be a little controversial because of the different social and environmental costs that are associated with them. For example, the costs associated with constructing a dam, it can be very, very expensive. The Three Gorges Dam, which is a dam along the Yangtze River in China, costs about $30 billion US. And during the construction of the Three Gorges Dam, the upstream area actually displaced and relocated over 1 million people. And so it does have some negative consequences. Another one, the Aswan Dam in Egypt, also constructed across from a river, a major river, the Nile River, resulted in the loss of many Egyptian sites and artifacts. So even though there are many benefits, oftentimes there are also some negative consequences associated with dams and reservoirs. We will move into chapter 18, talking about Aeolian processes, looking at the African Sahel and the Great Plains. When we're looking at Aeolian processes, this is pertaining to wind activity and wind's ability to shape the Earth's surface. So if we are looking at these processes, desertification is essentially a process where there is, I guess, past vegetated regions that gradually become more desert-like. Hence the term desertification. So this landscape, once very lush, is now relatively barren and is very susceptible to wind erosion. And so we can, take a look at some of those areas, and those areas that are more affected by these processes are going to be those areas that are arid to semi-arid. And of course, they are worsened by population pressures. And we're going to talk about a couple examples. The first one being the African Sahel. So if we're looking at desertification and how this how it impacts the landscape, this is one place that we want to kind of investigate and take a closer look at. So the Sahel region is in Africa. It is a region where humans have enhanced desertification. And kind of to back up, let me kind of give you a general overview of where the Sahel is located besides just in Africa. As you can see on the screen here, it is this area that is shaded in that darker color. It is essentially a narrow band that stretches across the latitudes between about 15 degrees to 18 degrees north latitude. And it also extends the whole width of Africa, starting on the west coast of the country of Senegal and extending all the way to the east coast of the country of Sudan. And if you can recall, this specific part of Africa often experiences both a wet and a dry precipitation cycle, depending on the movement of that intertropical convergence zone. So when the wet season occurs, which is typically between June and mid-September, the region gets a lot of precipitation and is considered their wet season. And then the remaining of the year, it's actually quite dry. And if we're looking at vegetation, the region lies essentially between the Sahara Desert to the north. So the Sahara Desert is located to the north, and to the south of it is where the tropical savanna, grasslands and open forest resides. And so, in other words, the Sahel region is referred to as ecotone because it lies between two distinct ecosystems, and it serves as a transition from one of those regions to another. So an ecotone is a transition region between two distinct ecosystems that contain species from each of those areas. So essentially a transition area. Let me give you a little bit more background information about the Sahel region before we kind of dive into more of the human interactions and results that have led it to this desertification. So The Sahel region was largely home to nomadic herders, in addition to small scale farmers. Uh, Typically, the nomads were residing more in that upper region of the Sahel and the drier parts, where the farmers were located more towards the southern part of that region, where it was more humid and where they received more precipitation. The nomads essentially maintained their small herds of cattle and goat, and they, follow the practice of moving their herd to find grass where their cattle could be raised. And that's how they lived their lifestyle. And it was a yearly pattern of a north and south migration across the region, essentially moving their cattle to follow the rain. However, the farmers typically tended to stay more in the southern region where it allowed them to be more successful in their farming practices. The people in the Sahel had to essentially evolve to this lifestyle, and it was, and they were able to be compatible with the carrying capacity of the landscape, which is essentially referring to the number of people living in an area where that number of people did not exceed what the landscape could support without degradation. However, things did change over time. And during the late 1800s, the European nations, mostly Great Britain and France, kind of parceled out this region into distinct colonial entities. So, with Great Britain and France parceling out the region into these entities, they instilled these artificial boundaries. And these boundaries became barriers to that yearly cycle of their nomadic migrations, their north and south migrations. Also, during this time, there was an economic focus that had changed from more of living within the landscape's carrying capacity to an overuse of raw materials and consumptions. When the colonial era kind of ended in the mid 20th century, the effects of the human behavior essentially remained in place. Uh, People became increasingly sedentary, which resulted in further cultivation of those fragile soils, overgrazing, and removing the trees for firewood. So during this time, there was an overall population increase. And because of the population increase, the landscape began to degrade more and more. And primarily because of this, carrying capacity was greatly exceeded the landscape's ability. It continued to degrade, and this is where we started to notice desertification of the Sahel, essentially reaching catastrophic levels during the 1960s and the 1970s. During this time period, it was coupled with a major drought. Basically lasted from then to present time. The drought resulted in hundreds of thousands of people and countless number of livestock that had died of starvation. There was an estimated 100,000 people that died as a result of these drought conditions of the Sahel in Africa in the year 1973. Another example of desertification is one in the Great Plains in the United States. Sometimes people in the United States think that these catastrophic environmental impacts, such as the Sahel, only occur in poor countries where people have relatively little education and economic opportunities. However, there are many examples of human impact on environmental and how they have environmental consequences throughout the developed world. One of those examples resides here in the United States. Maybe you have heard of the Great Dust Bowl that occurred in the 1930s. So the Dust Bowl is a region located in the Western Great Plains. You can see it on this map here. It is shaded in that darker color, just like the Sahel region was shaded in the in the continent of Africa. So this region that we are referring to included parts of many states. It includes parts of Colorado. It includes parts of Kansas and Nebraska, New Mexico, Oklahoma, and Texas. The climate of this region is semi-arid due to the rain shadow effect of the Rocky Mountains. Most of the vegetation in this area was relatively short grass or prairies is what we were kind of experiencing in this area. Beginning in, I guess, population increase started around the 1870s with the Homestead Act. The Homestead Act of 1862 was an act that essentially provided families or homesteaders with a free quarter section. And this quarter section was roughly about 160 acres, with just the understanding that that land would be developed in some way. And so, we had this Western expansion of population in the United States, and we did see that population start to increase. And as that population was increasing, I got to tell you one thing before we talk about more of that population increase. So that Homestead Act, which kind of drew people out towards the west and into this area here. Most of those grasslands in those plains areas were plowed during that settlement time. So often, many of those early settlers believed the claim that rain follows the plow. So if they plowed the land, the area would experience and change, and more rain would fall up within this region. So rain follows the plow is a phrase that was originated during this westward expansion of the United States, and it was a very popular belief among the settlers and the policymakers at that time that the act of plowing the land and cultivating the land in arid and semi-arid regions would actually attract more rainfall to those areas. Now, of course, this concept has been debunked by modern scientists' understanding. There was intense plowing and cultivating of this area as population started to increase. Disaster struck in the early 1930s, where a drought lasted for several years. And again, because the settlers kind of plowed the area, there were very little grasses on the land. Because they were plowed, the soils were exposed. And in addition, with the existence of high winds in the region, it caused dust storms. So this takes us to the Great Dust Storm. These storms blasted this area. They were very intense. Many of them being called black blizzards. The dust was so thick that in Kansas City, during the daylight, their street lights remained on. There was one specific day, April 14th of 1935, where there were 20 storms that occurred in this region, really turning day into nighttime, reducing visibility. And now they actually call April 14th is referred to as Black Sunday. And one of the, there's a couple of examples here of desertification with the Sahel and with the Dust Bowl of the United States. One of the best ways to prevent desertification is through soil conservation. And we will wrap up taking a look at chapter 19, which is looking at the different ways that humans interact with managing coastlines. Now, first thing that we need to do is take a look at not only why this is important, but we have a pretty large percentage of people that live within 60 miles of a major coastline, about 37% of people. So 37% of the people, and we're talking worldwide, live within 60 miles of major coastlines. Coastlines are a favored place with humans, with people. It is related to economic development, trade, housing, recreation, and again, with about six or more, it's more than that, billions of people living on this Earth surface. We have a significant amount that are living along those coastal areas. So given that we have many people in the United States and worldwide that live fairly close to the coastlines, it's important to understand the human impact of these sensitive areas, and how we are trying to stabilize many of these beaches. And of course, beaches are a main tourist destination. It also attracts economic activity. But we also need to take note of some of the potential future outcomes that are related to global climate change and the effects that has on the rising sea level, especially for those people that are living near the shoreline. So one of the most obvious ways that people impact coastal areas or coastlines is through engineered structures. And these structures can come in a variety of different forms. They're generally built with the idea that they want to protect the shore and the shorefront homes from coastal hazards and erosions, and even storms, and stabilizing and nourishing those beaches, and also maintaining, improving how the flow of trade or traffic into port. So these are all points that we're going to touch on in just these few last slides. One of the most common ways people attempt to mitigate coastal erosion is by building a seawall and revetments. So the difference between these two, a seawall is going to be built vertically, along that shore line, along that coast, to protect the structure. There are also some less elaborate ways that you can protect the shoreline, and oftentimes this is done with larger rocks, sometimes even cement blocks from old roads. And this type of protection is often called riprap, and it forms a revetment, and it's usually applied at the pre-existing slope rather than being built vertically. So really the main difference between a seawall and a revetment is that the seawall is built vertically, where the revetment, it just kind of follows the natural slope of the land. However, it is important to note that both of these examples, they are put in place to protect the property from erosion, but they can also cause extensive erosion up and down shore because of the wave power that is being deflected. One of the most primary reasons people like coastal areas is that they are very attractive to beach goers, and they're used for recreational purposes. And this is why it is an important economic activity that is tied to beaches and tourism. So it's important to note that sand is really easy to erode. And so um, there are some efforts that are being put in place to kind of offset that coastal erosion. And many communities have organized what are referred to as beach nourishment programs. One way that you can do this is by simply bringing in fresh new deposits of sand onto the beach where the sand has been lost through erosion. Again, essentially bringing in more sand to replace the sand that was lost. Now, of course, this is very costly, but if it's offsetting the economic activities with beach and tourists, especially in those areas commonly visited during spring break, Florida would be one of those states that invest a lot of money into their beach nourishment programs. Another way to maintain the loss of sand through erosion is by building a structure called a groin. So a groin is a low wall that's built at a right angle from the shore out a short distance from the water. This picture that I'm pointing to, I guess it's on the left-hand side here, is showing you a picture of groins along a shoreline along Lake Michigan in Chicago. Again, these walls are built perpendicular to the shore. Another option is building or constructing a jetty. So a jetty is going to be a long stone or concrete structure that essentially creates a canal between open water and an interior body to protect those waves. So again, a jetty is a long stone or concrete structure used to create a permanent opening by reinforcing both sides of those passageways. And so in this picture on the right-hand side, this would be an example of a jetty. In this picture that you're seeing, a typical jetty, this is on the Texas coast that provides a reliable passageway into the ocean for mini boats. And of course, we need to take a look at some of the environmental issues that we are facing today, one of those being global change. And with global change, we know that we have an increase of temperature. Not only are we experiencing an increase of temperature, the increase of temperature is warming the ocean waters. This increase of temperature is causing the melting of our polar ice caps and our alpine glaciers. And that meltwater ultimately returns to the ocean, which is causing our sea levels to rise. According to some scientists, sea levels appear to be rising at a faster rate than it was once predicted. And at the current projections, it indicates that sea level will rise anywhere from 8 inches to 6 feet by the year 2100. And of course, the impacts of this sea level rising on coastal areas around the world will be significant. On a global average, it's estimated that there are over 100 million people that are at risk for coastal flooding. Many of those residing in countries such as Bangladesh, Thailand, Indonesia, China, and the Netherlands. There is also concern in the United States, putting at about 8 million people at risk for flooding. The picture that you see on the screen here is those coastal areas of North Carolina. And of course, predicting, with sea level rising, what areas are going to be most affected. As you can see that the map is color coded, the red areas are those coastal zones that are less than 5 feet above sea level. Those areas that are shaded in blue, the elevation is between 5 and 11.5 feet above sea level. And so as you can see, much of the eastern part of the state is very close to sea level. And of course, the area that is shaded in red will most likely be impacted the most from the coastal flooding associated with sea level rising. Another reason sea level rising is a concern is that it will most likely increase the amount of damage associated with stronger storms and hurricanes. If you can recall, Hurricane Sandy that hit the coast, the East Coast of the United States in 2012 was a catastrophic storm. It was a catastrophic storm because when Sandy hit, when it made landfall, it was during a time where where that area has experienced the highest tide of the month. The storm surge that hit New Jersey and Staten Island, New York, was very intense and had extreme impacts on those coastal communities. And as we look at other areas around the globe, specifically the Pacific Islands region contains hundreds of low-lying atolls and volcanic islands, many of them where the maximum elevation is just about 10 feet above sea level, and they are already seeing the effects of of sea level rising. And another byproduct of global climate change is the impact that the warmer ocean waters are having on coral reefs and the coral reef systems. These systems are being affected by a process called coral bleaching. Uh, Coral bleaching occurs when the coral reefs are under stress, and they're under stress because of the warmer than normal waters. That stress loosens the algae that help feeds the coral building organisms. Because that algae gives the coral its color, the algae has less food because of that stress. And essentially, the coral is being starved, and that starved coral is lacking color. So it looks pale or it looks bleached. Ultimately, bleaching kills the coral. I can give you, many examples, but one example that I want to point out to you is Sumatra in Indonesia, where they are seeing over 60% of their corals being bleached, and an astounding 80% of species that have been lost because of the warmer ocean waters. So I spent some time with you today looking at river systems, arid and dry landscapes, and our coastal areas, and how humans have interacted with each of those systems. Now, if you have any questions or you want to talk in more detail about any of these processes, please feel free to reach out to me, and have a wonderful day.